calculate the current in the resistor here, because the voltage in that case is actually, the voltage is 5.8 volts and the resistance in this circuit is 13 kilo ohms. So that's why I'm saying the units, you must be very careful with that, because here is kilo and we know in physics that kilo is the same as 1,000, mega is the same as 1 million, because now in this case if you are given kilo ohms it means 1,000 ohms. If you are given mega ohms it means 1 times power 6 ohms. If you are given giga ohms, it means 10 raised to power 9 ohms. So these are some of the things that you need to be very, very careful with. Now, calculate the current. From this formula, we have said that voltage is equivalent to current times resistance, meaning that we can be able to rearrange this equation so that we are able to work out the current. And in that case, what we're going to say, our current is equal to voltage over resistance. And in this case, we are going now to take the voltage, which is 5.8 volts, divide by the resistance, and the resistance here is actually 13,000 ohms. This is volts. So if we work out this, if we use our calculator, we are going to get, this is going to be 5.8 divided by 13,000. If I just put that in the calculator, I'm finding my answer is that, so we can be able to write it in decimals. This is going to be 0.00. We can even write it in standard form, which is going to be 4.46 times 10 raised to negative 4 amperes, which is approximately 0.000446 amperes. We can be able to get it in that form. And if you're new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload new tutorials, you'll be notified. All through, we'll be working questions that are giving you problems. So there's every reason as to why you should subscribe, so that when I'm going to upload new tutorials, you'll be notified so that you cannot be able to miss any of my videos. So take this moment so that you can be able to subscribe, and also leave a comment down below if there is any question that you really feel, or if there is any section you've feel that you've learned something new. It will be very, very important for us. So we need to go to the next bit of this particular question. All right, so we need to move to the next part of this question, because we are told that complete the circuit by adding a suitable meter to measure the current in the resistor. Remember, a suitable meter in this case, we are measuring current. So current is measured using actually parallel to the component. So if we say voltmeter, we were supposed to add, in that case, we were supposed to add it at that point. So the correct answer for our question in this regard, actually this one. Don't be confused, because I've already mentioned as to the reason as to why I've added all. This one will measure the current in the entire system, in the entire circuit. This one will measure the current going through the 13 kilo ohm resistor, and this one here is going to measure the voltage drop across the potential difference of the 13 kilo ohm resistor. So we need also to look at the switch. This is the switch we are talking about of the circuit is closed. Explain what happens to the current in the 13 kilo ohm resistor. What happens to the current in the 13 kilo ohm resistor? Now, before we go to work out this question, there's some few things I need you to appreciate here. And that is when this circuit is actually closed, when this circuit is closed, we are going to have this resistor working and this other resistor also there. So the total effective resistance is going to be calculated by 1 over resistance R total over 1 over resistance. Let me call this is our R1 and this is as our R2. So which means that we can be able to say that we are going to add 1 over R2, this one here. So 1 over R is going to be 1 over 13,000, 1 over 200 ohms, which will mean that if we add this, what is it going to give us? R total. Let me just put it in the calculator so that we can be able to see what we are going to get. This is 1 over 13,000 plus it's taking long. Let me just move it quickly. Plus 1 over 200. It's giving me actually is giving me 33 over 600, 6,500, as you can see here. So meaning the total resistance here is going to be 33 over 6,500. So meaning that if we want to find R total, we need to find the reciprocal of the two. This is R total equals to 6,500 over 33. So if we work it out, we are going to get that value. I find the reciprocal of this is giving me actually 6,500 over 33. In decimal, that is 197, 197 ohms, 197 ohms. So something that you need to realize at this given point is that when this switch is closed, the total resistance in the system is 1. But if this circuit is actually open, the effective resistance, because this will not be connected, it will not be connected to be open. So meaning the total resistance will be 13,000 ohms. So which means when the switch is closed, resistance drops. Resistance of the circuit drops. So more current is going to flow. More current is going to flow through the circuit. So the current in the battery is going to be higher because the resistance in the circuit is less. So we're going to say current through the battery increases. The current increases, but here current remains the same. Current remains the same because voltage remains the same. Remember here, the voltage across this resistor is 5.8. The voltage across this resistor is also 5.8. So we mean that current in this part is going to remain the same because voltage and the resistance remains the same. So here we are going to say current through the battery increases because voltage remains the same, but resistance decreases. When resistance decreases, it means more current is going to flow through that battery. But since in this section here, I've actually repeated that since voltage remains the same and the resistance is the same, then it implies that the current from the resistor or through the resistor is going to remain the same. If you have learned something new from this particular video, consider subscribing so that when Prof Learn is going to upload another tutorial, see you in the next video. in this particular video, we're going to have a discussion how you can be able to calculate pressure in solids and pressure in liquids. The first part is identifying that pressure in solids is given by the formula force over area. So meaning that the force has to be in newtons and the area has to be in meter square. So in this case, we appreciate that pressure equals to force over area. So this is the formula you'll be using in any given point you are supposed to work out pressure in solids. And you need to appreciate that pressure in solids depend on two factors. That is pressure depending on force, pressure depending on area. The smaller the area, the higher the pressure. The smaller the force, the smaller the pressure. So you are going to realize that this is why if a lady who's putting on a high-heeled shoes and another person is putting on a closed and flat shoes, this one, because it has a small area, it means it's going to exert very high amount of pressure. Now, pressure in liquids is going to depend on other factors, like we need to write pressure in pascals is given by the formula. How do we calculate pressure in liquids? Pressure in liquids, we're going to say that's the height times the density of the liquid, and then we are going to multiply that to the gravitational field strength. That is a gravitational field strength. In that way, we are going to say therefore that pressure in has to be, let us identify this first, because this has to be in meters, density has to be in kilogram per meter cubic, and this is Newton per kilogram. So that's why we're saying now that pressure equals to H rho G, whereby rho is the density of that particular liquid. So we need to appreciate that fact. So meaning that if we are told this liquid has a given height, 15 centimeters, the density of this liquid, density, which is rho, is given by 1.3 grams per centimeter cubic, and the pressure inside here, pressure of the gas equals to 1430 pascals, because we have pressure inside this particular point. So if you are supposed to work out the pressure down here at point X, pressure at point X, we're going to say pressure at X is going to be pressure of the gas plus this pressure of the liquid column, pressure of the liquid column. I'm going to say pressure of the gas is, this one was given as 1430 pascals, 1430 pascals, plus pressure of the liquid column is going to be given by H rho G, height times density times gravity. So which means this is going to translate to 1430 plus height. We are going to convert this to meters by dividing by 100, and therefore that is going to be 0.15 times density. If we convert this density to kilogram per meter cubic, this density, these 2 meters, we are going to divide by 100, so this becomes 0.15. meters. Converting this density to kilogram per meter cubic, you only need to multiply this by 1000, and that becomes 1300 kilogram meter per meter cubic. So our density is 1300 kilogram per meter cubic times G. Our G is a constant. G is a constant, which is usually 10 Newton per kilogram. So that one also you need to remember. So that will mean that times 10 at that given point. So if we multiply all this, let's check the answer we are going to get here, because better. So if we put this in the calculator, we're going to 10.15. This is 0.15 times 1300 times 10. This translates to 1950. Pressure of 1950. So this is actually 1430 plus 1950. If we add the two, this becomes 3380 pascals. 3380 pascals. So the pressure at point X is 3380 pascals. So another question that you may be asked is how is pressure affected when temperature increases? How is this pressure at point X affected when temperature of the surrounding increases? How are you going to answer that? How is the pressure at point X going to be affected when the temperature around the surrounding is going to increase? How are you going to answer that? Now remember, we need to understand that here we are having actually gas, and these are just gas particles which constantly move around. So at this point we have these gas particles, and these gas particles, they are in a continuous random motion. As they move around, they collide with the walls of the container. So as they move around randomly, they collide with the walls of this container. So which means that they are going to exert a force. Yeah? When they move around, they are going to exert a force. So we have this particle moving around randomly. As they move around, they collide with the walls of the container, exerting a force. So if we are trying to answer the question to do with what happens to the pressure at point X when the temperature around is increased, it means that increase in temperature result to increase in the kinetic energy. Point one, increase in temperature increases kinetic energy of the gas particles. So when the kinetic energy of the gas particles increases, it means they are going to move quite fast, and they are going to collide more often to the walls of the container, exerting a large force, meaning an increase in pressure. And when this pressure increases, it also increases down here, because we said a pressure at point X is actually the pressure of the liquid column plus the pressure of the gas. This makes the particles collide more often, collide with the wall more often, exerting a large force, hence increase in pressure. So since there is higher pressure at this point, it will press the liquid down, hence pressure at point X is going to increase increase of pressure of the gas, resulting an increased pressure at point X. So that's basically what you are supposed to do when you are answering such kind of question. Welcome to our tutorial of Profline YouTube channel. In this particular video, we're going to discuss about motion in the universe. In motion of the universe, there are some key terms that you need to understand before you go and sit for this exam. One of the terms that you need to understand is the universe. What do we mean by universe? You can think that the universe is a large collection of billions of galaxies. Is a collection of billions of galaxies. And another term that also we need to look at, its definition is a galaxy is a collection of billions of stars. Now, once you've understood that, you may be asked to check if you understand the term solar system. And remember now, a solar system comprises of a star and planet. A star and planets. Now, because we have said that a galaxy comprises of a billion of stars, our galaxy, the galaxy that we are in, we can say our galaxy is called what? Our galaxy is called the Milky Way. Yeah, Milky Way. That one you need to understand. Now, after understanding those terms, you may be expected to maybe talk about orbits. And the orbits, remember, the orbit is a path through which a celestial body follows as it's moving around. So we will talk about orbits of planets, and we need to agree that the orbit of a planets actually orbit around a star. Planets, they orbit around a star, but satellites such as the moon orbit around a planet. Yeah, that's very, very key for you to remember. And the comets, they orbit stars. A comet orbit a star. So that's why you may be asked the question to give differences between the orbit of a moon, that's a satellite, the orbit of a star, and the orbit of a comet, and the orbit of a planet. Now, now these are different orbits that we have mentioned here. So you have body A, body B, and body C. So we are given that the sun is at that central point. So you may be asked to state which body is this A? What's the name of body B? What's the name of body C? And there are some reasons you are going to use, or there is some reasoning you are going to use in order to answer this particular question. So you can say identify the names of A, B, and C. We are going to identify the name of these bodies that are mentioned at that particular point. Number one, we have said the planets orbit around a star. So this one will only be a planet because the orbit is elliptical. The orbit of a planet is elliptical, but the orbit of a comet is very elliptical and elongated. It's kind of stretched. It's kind of stretched a little bit, and the sun is towards one end of that orbit. But for the orbit of a planet, the star is almost somehow at the center, but the orbit of the planet is kind of elliptical. So we can say A is a planet. A is a planet. Yes. B, because this body B is orbiting around a planet, it must be a satellite. We can say this is the moon. Moon. Satellite. So satellites, they orbit around planets. That's what we said here. And C is actually a comet. We are saying the comet because its orbit is elongated, is elliptical. So the force that is keeping this object in their circular path is the gravitational force, is the force of gravity. We are told to draw an arrow to show the way the force is acting is that you are going to draw an arrow directed to the center like that. So this object A is being pulled towards the center as it's moving around. Also for the object C is being attracted, so the force is acting towards the center of the orbit. So another question that you may be asked at this given point, if you are asked to give the differences between the orbit of a comet and the orbit of a planet. One of the reasons you will say orbit of a comet is elongated, very elliptical, but the orbit of a comet is elliptical, right? So that is quite important for you to remember. Orbit of a comet is very elliptical or elongated. While that of a planet is just elliptical. Yeah. So between comet and planet. So those are the differences But similarities, both orbits the sun. The two orbits are around the sun. You can see the orbit of a comet and the orbit of a planet. Both of them, they are orbiting a sun. So what about orbit of a planet and a moon? If you are asked a question to do with that, what are we going to say? Planets orbits around the moon, orbits around a planet. So that's one of the difference of the moon is circular. So similarly, if you are asked about the orbit, comparing the shape of the orbit of a comet and the orbit of the moon, you will say a comet's orbit around the sun, but the moon's orbit around planets. And something I need also to mention the differences between comets and the planets. This is a planet. Planets orbits is that the speed of this comet varies as it's going around its orbit. So at this point here, you may be told to identify where is this comet moving at a very high speed. Where is it moving very fast? Where is it moving very fast? So the comet is moving very fast at point X. Because at this point it's going to experience a very strong gravitational pull, so it's going to move very fast through that particular point. And at this point, Y is moving how? Is moving slowly. At this point is moving very fast, very fast. So meaning the motion of the comet around its orbit varies in speed. So kinetic energy of the comet at this point is very low because it's moving at a low speed. But kinetic energy at this point is going to be very, very high. So those are some of the things that you need really to remember as you are preparing for your upcoming. Another thing I need to mention, you may be asked in your exam is a question to do with orbital speed. How fast is this object moving around its orbit? So we're going to say orbital speed. Orbital speed, let me just see if I can write here. Orbital speed is going to be 2 pi r over t, whereby t is the time period. T is the time which duration this object is taking to go around its orbit once. So r is the radius, of the orbit. So need also to know how to work out these particular questions, so that whenever a question comes from motion of the universe, you'll be able to answer a question like that. And if you have learned something new from Prof Learn YouTube channel, we are going to do more on the topics that you really expect to answer in your exam. So you have reason as to why you should subscribe. Take a moment, like this video, comment down below if there is any video you are really expecting, so that anytime I'm going to check through, I'll be able to reply to you and then work on it. So make sure you remember all these concepts. Understand the definition, the universe, galaxy, the solar system. Understand the characteristics of all these orbits of planets, orbits of satellites, and orbits of comets. Understand if you are given orbits, you are able to identify which one is a comet, which one is a planet, which one is a satellite by looking at the nature and the characteristics of the orbits. Next, also, you need to understand the formula used to work out orbital speed, whereby we have said that orbital speed is equals to 2 pi r, where r is the radius of that particular orbit that maybe you will be looking at. And lastly, know the differences and similarities of all these orbits. Know the similarities of the orbit of comet and a planet. They are similar in the sense that both of them, they are orbiting a sun, a star. The difference is that similarity, we have said both of them, they orbit the sun or the star, right? That's another difference I mentioned, is that the speed of a comet around its orbit, it varies with depending on the position where it is, but the planet has a constant speed around its orbit. Number 3, understand now the differences. Yeah, I've mentioned the differences. The difference of the orbit of a comet and the difference of the orbit of the and to that of the planet is that the orbit of a comet is elongated, stretched, and very elliptical, but that of the elliptical. Now, the moon has a perfect circular orbit and it orbits around the sun. So basically, those are the areas that I expected to take you through so that you can be able to understand much that you discussed in your class. Have you subscribed? Right? So just subscribe now, right? And share this video to your friends so that they can also benefit. The table shows information about 3 electrical appliances. We have a lamp which is rated 40 watts. We have a cloth iron rated 2200 watts. And we have a television that's rated 110 watts. At one point, you might have used different electrical appliances in your household and you realize their power rating is indicated. For instance, I'm having a bulb here, and if I can be able to check it properly, the rating is 75 watts. The rating of this bulb is 75 watts. So have you ever asked yourself, what does that rating mean, 75 watts? What does it stand for? Basically, 75 watt means this type of bulb uses 75 joules of electrical energy in every 1 second. I'm having another type of bulb here, and this type of bulb is energy saver bulb, which is rated 18 watts. Now, compared to this one takes more electrical energy every second than this one. Similarly, when you are talking of cloth iron, you can see the rating here. It's 2200 watts. So it means in every 1 second, it's taking in 2200 joules of electrical energy. So meaning electrical devices convert electrical energy to the forms we need. If we need light, we're going to use the transducer, which is a bulb, which will convert electrical energy to light. If we need to iron our clothes, we're going to use an iron box, which is going to convert electrical energy to heat. In this video, we're going to discuss electrical power, electrical energy, and also questions related to mains electricity. So stick and watch to the end so that you can be able to understand how you're supposed to answer those questions. Before I proceed into that, if you're new to this channel, consider subscribing so that anytime I upload a video like this, you'll be notified. In Fimati Academy, we do one simple, giving you step right from when we had 0 subscribers to now we are over 1,000 subscribers within a very short period of time. consider giving this particular video a thumbs up, and also you can give a comment down below so that I can get to know what you like me to work on. Now back to the main agenda of this video. Part A, Roman 1, we are supposed to state the relationship between power, current, and voltage. Anytime you are given such a question, you are supposed to state a formula that you can use to work out any of the quantity that is there. So we can say power equals to current times voltage. If you use the symbol, you say P equals to IV. After stating this relationship, we can now be able to answer Roman 2 because we are required to calculate the current in the television set. We are told that the mains voltage is 230 volts. But remember, we are given the power rating. Therefore, since the power rating is given as 110, we can therefore say current equals to power divided by voltage. What I've just done here by rewriting the formula so that I can make current the subject of the formula. Therefore, our power is given as 110 divided by the voltage is the mains voltage that we're going to use here, which is 230. If you use our calculator, we're going to work that out as, let me get my calculator here. So if I can divide 110 divided by 230, I'm getting 0.48. 0.48 amperes. Remember the units for current. The closed iron cable has 3 wires, and I say that's the earth wire, neutral wire, and the live wire. Which of these wires is connected to the fuse? Remember, the earth wire is there for safety purposes, so that you are protected against electric shock. The neutral wire has 0 potential difference, and its purpose is to complete the circuit. And finally, the live wire carries the potential difference. So the fuse is going to be connected to the live wire. This should be the live wire at this point. Roman 3, we are supposed to suggest why the lamp is safer to use, even though its cable only has 2 wires. We saw a cable of a bulb was not having the earth wire. The reason as to why it's safe to use a lamp in this case is because it's taking in very little amount of current, and at the same time there is double insulation. Double insulation is meant to protect the user so that it doesn't come into close contact with the electric current, whereby it can be able to get an electric shock. So we need to move to the next question, whereby we are told that the lamp is switched on for 55 minutes. Calculate the energy transferred by the lamp. Energy transferred by the lamp is given by the formula energy equals to power times time. So we need to ask ourselves, what's the power for this lamp? And we saw the power was 40 watts. So we're going to write here 40 watts times the time. Our time is given here, which is 55 minutes. And time should be in seconds. So we need to multiply by 60. So if we work out this, we're going to get our answers 132,000 joules of electrical energy. You can as well divide this by 1000 so that you can get your answer as 132 kilojoules. Basically, that's how you're supposed to work out that question.